The next topic in GAE is data store. Here we are going to discuss about difference between GAE data store and relational database, entities and models, keys and entity groups, CRUD operations and the GQL, queries and indexes, transactions and additional data store features. Difference between GAE Datastore and relational database. GAE Datastore is built on top of big table, whereas relational database depends on database management system. GAE Datastore is schemaless object datastore. The objects in GAE Datastore form a hierarchical structure same as a file system. It mainly differs in relationship between data objects. It is designed to scale to maintain high performance. All the queries are served by pre-built indexes. Unlike relational database, data store doesn't require entities of same kind. Some of the things which not supported by GAE are join operators. We can't perform join operations in GAE. Inequality filtering on multiple properties is not possible. Filtering of data based on results of subquery is not possible on GAE Datastore. Entities and models. What is an entity? Entity is an object in App Engine Datastore. Each entity has its own key which uniquely identifies. Datastore entity is of particular kind which categorizes the purpose of queries. An entity begins with root entity and proceeding from parent to child, which forms an ancestor path. Each entity has an identifier assigned when the entity is created, which acts as a primary key in our relational database. How can you create an entity? Entity E equal to new entity of person. We are creating an entity without passing an identifier to the entity. Setting the properties first name, last name and email. So entity E is an object from google.appengine.api.datastore, and person we mentioned here is of particular kind, like employee in a company. And these are the properties: first name, last name, email and the values. We are giving properties and values to the set property method of the entity E. Let's go and create an entity in Eclipse. Go to the project, new web application project, create GAE Datastore, give a package name, Datastore, and uncheck the checkbox, click on finish. A project has been created with the following structure, consisting of source having a package and meta-env with App Engine SDK, GRE libraries and var file, which consists of web.env, JSPs and libraries. You can find web.xml, appengine.xml. Let's try to create an entity. We can create entity in two ways. Create an entity without identifier. Entity E equal to new entity of we need to pass kind. a person, person. We are not passing any identifier. Set the parameters. First name, Tom, last name, filer. So we have created an entity with a kind person without passing an identifier, and we set the properties. Go ahead and run the program. The server is up and running. Go to the browser and provide the URL. GAE Datastore is hello, welcome to GAE Datastore. Check in the console, which is admin. This admin console. Check whether we have any entities have been created. As we have not persisted any entity, there is no entities in our console. Go ahead and persist the entity. In order to persist the entity, we need to create a Datastore factory. Datastore service factory dot get Datastore will give a Datastore service object. By using this, we can persist ds dot put off, provide a key e to in put method. Go ahead and run the web application. Invoke the application book. Go ahead and check in admin console. A person entity has been created of particular kind. List the entities with the name, first name Tom, and filter. Change the values. Jerry, Hitler. Invoke the application and check it out. It has been created with different entity with Jerry as first name and Hitler as second name. Like this, we can create multiple options. When we invoke the application multiple times, we can see the same record has been inserted thrice. There is no, without sending, we are not sending any identifier to the entity, so the entities have been duplicated. How can we make it distinct? How can we make it unique? We can make the entity unique with the help of identifier. By creating an entity with identifier, we can make that entity as a unique entity. User equal to new entity of user. I am trying to provide key as 415. Try to set the properties. user ID 4 and 5, username, Kevin, password, and age. Try to persist the entity. And launch the application. So we have set 4 and 5 as the identifier to the entity user of kind user. Launch the application. We have invoked application. Go to the console and check whether user entity has been created or not. User entity has been created with the ID 4 and 5, with the Kevin Gmail, password and user ID and username which you have mentioned over there. If you invoke the application couple of times, let's check and check whether the user has been, any entity has been added to the user or not. When you refresh it, see no entity has been added. If you go to person, the entities are adding. Why? Because there is no unique identifier. So we can make a single entity as unique with the help of identifier. So identifier plays a key important role in an entity. Also, batch entities. If you want to add 3 to 4 entities as a batch to the data store, create entities first. Of kind employee, I have created 3 employees with 3 entities of kind employee 1, employee 2 and employee 3. Try to persist as a batch. For this I need list of entity with e4 equal to arrays dot as list of, we need to provide entities as parameters and persist it with the data source ds of e4. So we have created 3 entities and we make it as an array list by passing entities into the parameter, and we are persisting as a batch. Try to launch the application. Application is up and running. I invoked the application. Go to the console and check whether entities have been created or not. I have created 3 entities, employee 1, employee 2, employee 3. So all these things are created as a batch. What is a model? In a Python API, a model describes a kind of entity, including the types and configurations for its properties. An application defines a model using Python classes with class attributes describing the properties. Entities of a given kind are represented by instance of the corresponding model class. Model is a superclass for data model definitions defined in google.appengine.ext.db. Let's see how can we create a model. So here model is a superclass of ext.db. So we have created a model with the help class contact of passing db.model class as a parameter to our model contact. We are setting the properties with the help of db.string property. We are assigning a string property to the variable name and assigning text property to the variable body and datename property to date. Here how can we instantiate with the help of constructor contact of and assigning to an object con. By using con.name equal to Shankar, we are assigning a values to the variable name, body to variable body. Entities and models. These are the key differences between Java entities and Python models. While time of creation of kind, in Java entity depends on its kind while it's instantiate, while Python model is determined by its model class. Creation, identifier creation, key creation, ancestor path creation, create or update an entity, get an entity and delete an entity. We'll discuss about keys, ancestor paths and CRUD operations in the following topic. Keys and entity groups. Keys. An entity is uniquely identified by key. Key consists of entity kind, an identifier with key name, a string or a numeric integer value, an ancestor path. Entity key is immutable. Once an entity has a key, it can never be changed. Key factory is used to create key for entity which takes kind and identifier as a parameter. Key factory.builder is used to create key for ancestor path. To designate an entity's parent, provide the parent's key to child entity while creation. If you want to make a parent to a child, just pass the parent key to the child entity's argument. For example, user is an entity of kind user. Creating a key for the user with the help of key factory by passing user ID as a parameter, and another entity address, we are making address as child to the user by passing user's key to the address. We are making user as a parent to address. Key factory.builder used to create ancestor keys. Here we have created great grandpa is the parent, which is root entity. We are adding a child grandpa to the kind user to the parent great grandpa and dad to grandpa. So it is making a parent-child relationship and making a ancestor path. So by using key factory.builder, we are able to get a key of the ancestor entity. Let's go ahead and create the key in Eclipse, and with key factory.builder we can get the ancestor key. Creating a key. key equal to key factory dot create key of string ID user if you want to get a key of our 415. Try to print the key. So I have created with a key with the help of key factory for the 4 and 5. Run the application. Invoke the application. So 4 and 5 has been created and the key value is user of 4 and 5. So we can create a key. Creating ancestor key. Key 1 equal to key factory dot builder of user great grandpa dot add child of user grandpa add child of user dad. I'm invoking get key of. So let me print this key 1. So with the help of key factory dot builder, I am able to get the ancestor key. Run the application. Invoke the application, and we can see here the key value of the key 1 is grandpa. Great grandpa is a parent of grandpa and grandpa is a parent of dad. So we can get with the help of key factor builder. Entity groups. Every entity belongs to entity group. A new entity can assign to an entity group by supplying the key of another entity. Every entity with a given root entity as an ancestor is in the same entity group. If in the previous example the grandpa is the ancestor for the dad, so in the sense both grandpa, dad and great grandpa are in the same entity group. For example, key, mboard key, we are creating a key for mboard key, message board kind, and message is a new entity. We are passing mboard key as a parameter to message. So we are making both mboard, message board and message in single entity group, in the same entity group. Let's create an entity group. Entity employee equal to new entity of employee. We are passing comma, we are passing user key as a parameter to employee, and we are making employee and user in a same entity group. This is how entity group can be created. CRUD operations and Google query language. CRUD operations. For CRUD operation, nothing but creating an entity, updating an entity, deleting an entity, and retrieving an entity. In order to do these operations, we need Datastore. First, let's instantiate the Datastore with the help of Datastore service factory. And create entity, set the properties, retrieve or update an entity with the help of Datastore.put. Retrieving an entity. We need key of the particular entity in order to retrieve an entity of a particular kind. The Datastore.get method with the parameter key is used to retrieve an entity from the Datastore. Deleting an entity user. By using Datastore.delete of particular key, we can delete an entity from the database. Let's trial in practical. So we need to instantiate Datastore first. We have instantiated Datastore DS with Datastore service factory, and with the help of ds.put we are creating an entity. Now stop the server. We are creating an entity of key 417 with the name Peter. And which age is 55. Run the application. Invoke the application and check in the Datastore whether the entity has been created. The 417 is created with the name Peter. If you want to update an entity, change the parameter, the property Peter to Peter Hein, and age to 56. So we are trying to change the parameter of an entity user of n key 417. And the application. So with the help of same method Datastore.put, we are able to create an entity and update an entity. Go to the console and check the 417 is updated with the Peter Hein. Launch the application and Peter Hein has been created. So creating entity or updating an entity. Now if we want to retrieve an entity, ds dot get of, we need to provide key. So already we have created a key, we use the same. So this we are passing key 4 and 5 in order to retrieve from the data store. This will throw entity not found exception, which we are keeping in try catch. So let's go ahead and launch the application. The run type of the get method is entity, so I am trying to print the entity E5 which is getting 4 and 5 key entity. Here we go. We have requested 4 and 5 entity, and when I am trying to print the E5, which is ds.get of key, which will retrieve with the user ID 4 and 5, age 35, email, username and password. This is how we can retrieve the data of entity from the data store. Now try to delete an entity. We can delete an entity with the help of ds.delete method. We are passing key as a parameter. Let's create an entity. Launch the application. Invoke the application. We are trying to delete an entity with the name 4 and 5. Refresh it. The ID 4 and 5 is deleted from the data store with the help of ds.delete method. So we have tried to create an entity, we have tried to update an entity, we have tried to retrieve an entity with the help of get, and now we are trying to delete an entity. So these are the CRUD operations in GAE. These are the CRUD operations in GAE. Then GQL. GQL is a SQL-like language for retrieving entities or keys from App Engine data store. The syntax for GQL is select property list or a key from which kind, whether it is people kind, user kind or employee kind, where condition, order by ascending order or descending order, limit to particular count and offset to particular order. Every GQL query always begins with select star or select with a key or select with a property list. From class limits the result to set of entities of given kind, where class filters the result set. GQL does not have OR operator, however it does an IN operator which provides a limited form of OR. examples. If you want to find all the entities of a person kind whose ages are between 18 and 35. To find the entities of the person kind whose names are one of the Kevin or Peter. To find the keys of the entities of the person kind that have an age of 58, we can use a select queries in order to retrieve the data from Datastore using GQL. Queries and indexes. A Datastore query retrieves entities from Datastore which operates on entity values, keys to meet specified set of conditions. Datastore API provides a query class for constructing queries and prepared query class for fetching and returning entities from the Datastore. These two important classes, one is query and one is prepared query. A typical query includes an entity kind to which query applies, 0 or more filters based on entity property values, keys and ancestors, and 0 or more sort orders to sequence the results for ascending order or descending order. Good. How to create an entity? With the help of query class, we can create an entity of particular kind. Fetching and returning from database with the help of prepared query. Datastore.prepare of queue which fetch the results from the Datastore. We can iterate the data and then we can print the data. We can also perform sort orders and filters on query. Example, with the help of add filter, we can filter the age who are less than 50. With the help of sort parameter, add sort, we can sort the names of the entities in ascending order or in descending order. There's a couple of restrictions for queries. No user of filters that match entities missing a property. Inequality filters are allowed on one property only. We cannot apply for multiple properties. Query ordering when sort order is unspecified. Let's go ahead and create query and prepared query and apply some filters and sort orders. So we are trying to retrieve some of the data from the database. Query queue equal to new query of particular kind. I am passing user as a kind. By using prepared query pq equal to ds dot prepared query of, we are passing q as a parameter. Now we are trying to iterate the prepared query. So the U1 got get property of user of a property built in an object. So we need to convert to string by using toString. So like this, we need to get the data from the data store. If you have couple of entities in the data store, it will all the entities will be retrieved and put it in the PQ object, and it will iterate and display the result, like same like a result set in our database, relational database. So I am trying to print the username and password. Try to run the application. Check in the console. We have 3 entities. It has to return 3 entities and has to display. Invoke the application, and we can see here the user ID 3 entities have been retrieved. 416, 417, 418 has been retrieved with the help of query. We are retrieving the data from the data store. Let's apply some filters to the query. How can we apply the filters? By using add filter of age we are passing filter operator, which consisting of the greater than or equal, less than or equal. I am printing greater than, age greater than 30. So it has to print age greater than 30 is 416 and 417 entities. Try to run the application. Invoke the application and check the result. So it has been invoked only 416 and 417, which are ages greater than 30. Like this, we can apply filters on the particular query for the particular result. Let's add some sort orders. Dot add sort of. Let's take username, property, and which direction you need. Query dot sort direction dot I'm giving ascending. So what it will do is it will print the username entities in an ascending order. Try to run the program. Check the application. The username is Kevin, Hunk, Peter. It has to print Hunk, Kevin and Peter in a ascending order fashion. So invoke the application and see the username is Hunk, Kevin and Peter, which is printed in the ascending order fashion. With the help of add sort, we can print the entities in the ascending order. With the help of add filter, we can filter according to our conditions. Indexes. An entity is defined on a list of entity properties of an entity kind with a corresponding order, ascending order or descending order. An entity index table contains a column for every property specified in the index definition. The data store index identifies the index that corresponds with the query's kind, filter properties, filter operators, and sort orders. App Engine predefines an index on each property of each kind. These indexes are sufficient to simple queries. For other queries, the application must specify the indexes in datastore-index.xml, which automatically creates when you deploy your application to App Engine. We can customize your datastore-index.xml as per your application requirement. The key indexes features. Datastore maintains and uses indexes for every query that an application uses. An index is a table which contains the result for each query in the desired order, continuously updating as the queries are executed. This is one of the key features. With the help of this, if backend is any changes in the data, automatically it got updated with the help of indexes. And also the queries are performed based on the indexes, and the results are computed using one or more indexes. The table contains entities in a sequence specified in the index properties. Here are the key features of indexes. Transactions. A transaction is a set of data store operations on one or more entity. It's necessary to handle when other user is attempting to create or update an entity with same string ID, mainly in banking applications. It's atomic, means transactions are never partially applied. Transactions can also perform on entity groups and cross groups with same groups, or if the entities belongs to different group, we can apply transactions. We can see with an example. Transaction supports isolation and consistency. It also have a possible to queue the transactions. Example. How can we create a transaction? By using datastore.begin transaction, we can begin the transaction. Create an entity, set the properties, and do the operation transaction.commit. So once we committed, the data is to be stored in the database. If you face any problem over here, the data will be rolled back at the final statement. The transaction will be rolled back and the data is not going to insert on the data store. You go with an example of transaction. How can we perform transactions? Transaction coming from data store tx equal to ts dot begin transaction. This is how we can begin the transaction. Once after our operation, we can commit the transaction with the help of transaction dot commit. So the two main functionalities in the transaction. So we can check this with the finally using try catch block. tx dot is active, then I'm going to say tx dot rollback. Change the data to 419 Sputnik. And try to commit the transaction by invoking the application. invoke the application, the transaction is committed. Go to the console and we can check with the 419, the transaction is committed with Sputnik having password 1. Like this we can begin the transaction and commit the transaction. We have done the transaction. Let's take example we have done in a user parent. Let's do the transactions on child. Child transactions. Let's create a child address, new entity of address. I am passing user dot get key as a parameter to address and making address and user into same group, and try to commit the transaction. Go to application, invoke the application. We can see in the console whether the entity address has been updated or not. Storing the address. So now we can see this, there is no address entity. We are making the address entity with the putting user as a key to the address entity. Save it and run the application. Now address entity has been created with the ID name is 46. So we can make a transaction so that we can say this user and the address in the same entity group. If you want to make a transaction on different entity groups, then we need to use cross group transactions. For example, phone is a new entity of different group. So I have taken 3 entities. One is user entity, one is address entity, and one is phone entity, in which user entity and address entity belongs to same group, whereas phone entity belongs to different group. So try to put in the database. We'll see an error, illegal argument exception, as both phone entity is different entity group from user entity group. Let's see, try to compile this. Launch the application, we'll get in 500, and you will see that can't operate on multiple entity groups in a single transaction. And before, when we do a transactions on user and address which belongs to same group, by passing user key to the address variable, the transaction is success as they are in same group. Whereas phone, we are not passing any parameters, so it treats us in a different entity group, and if you make a transaction, is failed with the error saying can't operate on multiple entity groups in a single transaction. If we want to achieve cross group transaction, we want transaction options. Let's try to build transaction options. Transaction options dot builder dot with xg boolean is we are putting cross group transactions property to true and passing transaction options to the transaction, and then we need to commit with the help of transaction options. So we are sending transaction as a parameter to the put. Now try to invoke the application. So we can perform transactions on same entity group. Also we can perform on cross entity groups with the help of transaction options. Invoke the application. Now it has been success. Why? Because we can made with the help of transaction builder. So one of the key feature is we can make transactions on same entity group and also cross group transactions. Additional data store features. One of the additional advantages: no planned downtime, atomic transactions supported, high availability on reads and writes, strong consistency for reads and ancestor queries, eventual consistency for all other queries. A property can reference another entity. This is one of the additional features in GAE Datastore. Have a sample application which we can host in GAE in outside world, and we can test the functionality. Go to the Eclipse, import the project. Demo is a sample application which is having login functionality, which performs some CRUD operations, which performs some transactions. The whatever topics we have discussed till now, we can show in a simple application which is demo. Running the locally first, and go to the browser, the URL. A simple application, web application coming from the local server. Try to sign up with the user. Anthony Joseph. Username is Anthony. Password I am giving Anthony. gmail.com, which age is 100. Submit this. Welcome to Innobus homepage, and this is a homepage serving from local GAE server, and when you click on the register, it invokes one of the CRUD operation. Also when you click on the show users, it will invoke one of the CRUD operation and display the result. Now the same application we are going to deploy in the GAE server outside the world. Now go to appengine.google.com, Innobus GAE with the password create an application. Create an application with application name as GAE Innobus GAE Datastore, and check the availability. Available application is GAE Datastore, and create an application. Your application has been created successfully. Now go to the application and get the ID, go to our app engine -web.xml, to Innobus GAE Datastore, change the application name, the version 1, save it and deploy it to Google App Engine. We need to provide the username and password. Allow access. Project name to deploy. Now it is going to deploy the application, web application, which consisting of all the data store operations and transactions to GAE platform, which is in cloud. It takes a couple of seconds to deploy the whole file into the GAE. You can check here the functionality, the verifying availability and the uploaded files, and any updated files is uploading into the GAE cloud. Deployment completed successfully. Go to your application, appspot.com. There you go. Now we can check the URL. We are invoking from the cloud, so we have deployed the application successfully. Now go to the dashboard, and check the data store, whether is there any data store has been created in your GAE Datastore. Try to sign up with the user. User ID is Akshay, Rathod, name, username Akshay, password akshay@gmail.com, age is 25. When you click on submit, it has to register and it went to welcome.jsp. Let's first go where exactly it went. First, when your app engine deployed the application, the first URL is go to web.xml. The welcome file which we mentioned is login.jsp. So the welcome page which you are getting is a login. The next action we are going to do is register. When you click on the show user, it is a login.jsp. We mentioned href, which is new user sign up. When you click on new user sign up, it has to go to register.jsp. Go to register.jsp. We have mentioned username ID, name, username, password, email, age, and click on the submit button. This is what you are able to see here. This is a registration form with user ID, name, username, password, email, age, and submit. When you click on the submit, it go with the action register. Check in the web.xml with the /register. The URL pattern matches the URL pattern. The form register is matched with the URL pattern, and the JVM trying to invoke the register servlet. As servlet name is register, trying to invoke register servlet. When you go to register servlet, the functionality, with the help of doPost method, we are getting the parameters from the register.jsp and setting to the local variables, and we are performing some operation, create or update an user by passing the parameter. So this create or update method is of user. We have created a utility class which is user, where we are performing all the DB operations. So we are passing user ID, name, username, password, email and age to create or update method. When you go to create or update method, we are passing entity to Datastore dot put of e. So it is creating an entity into the Datastore, and once it has been created, it comes to welcome.jsp. Once everything is done, it comes to welcome.jsp. Why? Because we have mentioned in register servlet we are using request dispatcher. Go to home page. In the home page, if it is registry is unsuccessful, go to again register.jsp. Once registration success, go to home page. In the home page, we have mentioned welcome to Innova's home page, and we have one href which is show users, and we have one form which is having delete. So let's try to get the show users. Show users, when you see the href of show users, go to web.xml, which checks the show users as the URL pattern. Once URL pattern is matches, then it invokes the show users servlet. Go to show users servlet and get the parameter which we are sending over there. So we are getting all the parameters, and we are invoking again list user is a users method which is a DB query. So go to list users, there we are retrieving all the data with the help of add sort method. We are printing the data in the ascending order and iterate the data and populating it to the front end. So show users will show the data on the show user.jsp. Once we invoke the show users, it will show the list of users that are present in the which we created just now in the data store. Try to create some more users. So I have created a couple of entities, and when I invoke on the show user, it will show all the entities in the database. If I want a particular entity to delete, give the ID and click on the delete button. So in the show user, let me take Teja as the user ID. When I give Teja and delete, it will show the user deleted. You can go ahead and check in your data store. So when you see here, these are the data that have been updated or created with the help of CRUD operations in the data store. So just now we performed the delete operation on Teja, so we can't able to see the Teja entity in our dashboard. So when you click on the delete submit button, it comes to delete.jsp. There we enter insert.jsp. Go to delete. We are performing with the delete user. Delete user, it takes the ID, it's a user ID as the parameter, and invoke the created a key and invoke the delete method of data store by providing the user key. Once you provide the user key, that particular ID got deleted from the data store. we can perform couple of operations in this. Now let's log into the application. So when you see in our data store the username and password, let's take vkk123. I have given vkk123 as a password. Let's try to log into the application. I have given username and password as same, so it is successful, and we are coming to welcome to Innobus home page, and again we can see show users. So vkk123 is a username and password which we are trying to edit. This is a sample application where we can perform all our data store operations. So we can log in with Akshay with ABC123. If you given wrong password, let's take I am giving some dummy password, not able to give an account login, it redirects into account login. The functionality is once it comes to login page, we are given when you click on the submit, the form calls with the action as a login. It goes to web.xml and search for the URL pattern login. So searching for login, URL pattern matches, it invokes the login servlet. When it goes to login servlet, it is getting the username and password, and it is calling the db method get username and password, and we are creating a query to retrieve the data from the data store and fetching the result. And once we've got the username and password, we are just a simple condition to send the user to the main home page or to the login page. This simple application we can use delete and operations, getting the entity from the data store, and we can update the entity from the data store. So try to update an entity. Let's take for the VKK ID, I want to update the username and password. So enter the update username as Innobus. Email is innobus@innobus.com. Some 200. When you submit on this, and when you check the show users, the VKK entity has been updated with the following things. The VKK user ID has been updated with the name Innobus and username Innobus and password is Innobus. We can try to log in with the Innobus username and password. This is how the operations have been performed. So this is a simple application.